We can get a little bit into timing, but I do believe that the best time to take these NAD plus precursors is first thing in our morning or, with breakfast, but sometime early in the day.
You can just bang it out in the morning.
NR, like in an animal model, actually rejuvenated stem cells in the gut. They have a potentially really big impact on our digestive system and the gut microbiome.
It's a molecule in incredibly high demand.
Pretty widely established that NAD depletion would be the tipping point for cells to become senescent cells.
Hi, listeners. New Frontiers in Functional Medicine has been going strong since 2015. With almost 200 episodes and over 2 million downloads, my goal is to bring you the best minds in functional medicine, epigenetics, and longevity. I want actionable insights for the clinician and non-clinician alike. You can access episode transcripts, summaries, research citations, and more over at drkarafitzgerald.com, where you can also find information about our clinic and sign up for the e-newsletter as well. Thanks for supporting this podcast with your likes and your honest reviews, by sharing this with your colleagues, with your family and friends. Thank you also to our sponsors. These are companies that I trust, that we vet carefully, that we use in clinic practice, and that I use personally. Hi, everybody. Welcome to New Frontiers in Functional Medicine, where we are interviewing the best minds in functional medicine. And of course, today is no exception. I am once again with Dr. Greg Kelly. Let me tell you his background, and we're going to jump into what will be a great and really first-time conversation on all things NAD. And I will just add, Greg, in case I forget, there's not a day that goes by I don't get, at least one question on NAD. So this is an important and timely and really overdue topic on our podcast. Dr. Gregory Kelly is VP of Product Development at Qualia Life. He's a naturopathic physician and author of the book Shapeshift. He was editor at the journal Alternative Medicine Review, where I first met him, and has been an instructor at University of Bridgeport in the College of Naturopathic Medicine. He taught advanced clinical nutrition, counseling skills, doctor-patient relationships, and he's actually done a lot of stuff over there. He's published hundreds of articles on natural medicine and nutrition. He contributed 3 chapters to the seminal textbook of natural medicine. He's got more than 30 articles indexed on Pubmed. His areas of expertise include nootropics, anti-aging and regenerative medicine, weight management, sleep, and the chronobiology of performance and health. Greg, it's really great to have you again on New Frontiers.
Oh, thank you for having me. It's always wonderful to get to talk with you.
And today we're going to talk about all things NAD, but I do actually, before we jump into this, want to let people know that there's a discount. There's actually a really, really great savings opportunity if you want to try the Qualia NAD. So just go to qualialife.com/Dr. Kara Fitzgerald to try their NAD product. And we're going to talk about how, Greg and his team formulated it. You can get 50% off of it. And then if you use the code Dr. Kara Fitzgerald on top of that, you'll get an additional 15% off at checkout. So it's a great deal and a great way to get in to check out, and do your own experiment on NAD. So why don't you just, first of all, introduce anybody who doesn't know to what exactly NAD is, and start by just defining the acronym.
Yeah, so NAD stands for nicotinamide adenine dinucleotide. And when I would have taken biochemistry in 93 or so, NAD would have been something I learned about. So it's always been an instrument, or known to be an instrumental part of physiology, going back to the late 30s when, with the deficiency disease pellagra, the original people sorted out that the end part of that, nicotinic acid or niacinamide, was the deficiency that led to that syndrome. And we'll talk maybe a little bit about symptoms of that. But I think what really changed was somewhere the late 90s, early 2000, with the big names are people like Warranty and Sinclair and Brenner, that started to find that NAD had these other, what are often called consumption roles, that were beyond what its redox, and redox kind of NAD plus NADH kind of flipping back and forth. So what that means. And with that consumption roles, it was found that to activate enzymes called sirtuins or enzymes called PARPs, and PARPs have to do with DNA repair, that the NAD plus molecule was consumed. And that kind of was fuel for these enzyme systems that tied into longevity. And I think that's really what led to the rebirth in interest in NAD. Yeah.
Well, let me just circle back, and because I just want to tease something out. Most of us, I'm a naturopathic physician, and anybody who's done probably training in any form of clinical medicine has encountered medical biochemistry and knows the redox of NAD, happen in oxidative phosphorylation, I guess perhaps one of the most famous roles for NAD. And that in that setting, it's recycled over and over again. Hydrogen's added and subtracted, and in so doing, it makes it's fundamental to using oxygen to make ATP. Kind of incredible, but it's recycled. And you're saying, I just want to make sure, like in these other roles, in these anti-aging roles, in this area that we're now sort of really clearly seeing, NAD declining with age, is it actually spent or is it recycled?
It would be recycled to some extent. So what would happen if, we'll just take the sirtuin enzymes, they would consume the NAD molecule as part of that. And it would then be broken apart into like niacinamide, NAM is the abbreviation for that. And then the NAM can be recycled or eliminated. The other big chunk of the molecule can also be recycled, but it's consumed in the sense that it's broken apart. And just to put it, I guess, a frame of reference, you mentioned the ox phosphorol, right, making ATP a carrier for electrons. And riboflavin does that also, right, with the FAD and FADH. And the DV for riboflavin is a little less than 2 milligrams. And for B3, it's way higher. It's 16. And that's probably because instead of just toggling back and forth in the oxidized and reduced state, the niacinamide NAD molecule is actually consumed and broken apart. Right. And that salvage is less efficient than just flipping back and forth.
What is it? I mean, so you touched upon it's, the scientists who sort of started to champion it and characterize its roles in, the aging journey, the aging phenomena. And we think about aging sort of with the hallmarks of aging frame of reference, which we talked about actually on our last podcast. So we'll make sure that that's linked in the show notes. So where's NAD in the hallmarks?
So like stepping back, I think of NAD plus having three main roles. So we touched on, two, the first being that, making ATP. The second, we touched on some of the consumption roles, the DNA repair. So sirtuins have a lot to do with metabolic stress response. And then NADP, NADPH, that's about building molecules. So that would be involved as an example in glutathione synthesis. So the third major role is about cellular resistance to oxidative damage and others. So I think of those as three main jobs with then many, many minor jobs.
Right.
And in terms of the hallmarks of aging, there's some thought that NAD plays at least some indirect role in all 12 of them. But for sure, like direct roles, mitochondrial dysfunction. So with mitochondrial dysfunction, what you would classically see also is NAD plus levels inside mitochondria decreasing with age. DNA repair is another one. And so the PARPs, those enzymes that NAD plus provides the fuel for, are directly tied into that DNA repair thing. Cellular senescence is interesting because one of the main things that Charles Brenner would say about NAG, if you pressed him, okay, what does it really do? He's said to me, it's about metabolic stress. And when cells are stressed anyway, metabolically or otherwise, they kind of have a few different options, but ones, they get tougher, right? They build up their defenses. Two is they're damaged to some extent, right? DNA is damaged. Proteins get misfolded, so autophagy then would be the repair mechanism, or there's more damage and they become unrepairable, so a senescent cell. And it's pretty widely, I think, within some of the research community now established that NAD depletion would be the tipping point for cells to go through one of those two doorways. So if they're depleted in NAD, they're much more likely to become senescent cells, as an example. And then senescent cells, to fuel their SASP, right, the pro-inflammatory things they secrete, they rely on NAD. So they tend to be voracious consumers of NAD. So
interesting.
That's the senescent cell connection. And then,
so the fate will be increased vulnerability to turning into a senescent cell, but once done, it's going to steal all the NAD. So there's
correct.
like just two layers of good-sized problems. Yeah.
And part of the SASP is, right, it's pro-inflammatory. It's kind of that inflammaging piece. And it's why NAD is thought to, in part, plummet as we get older, because of that inflammation is just consuming more of its share with less left over to drive DNA repair and the sirtuins, as an example. Dysbiosis is another interesting one because there's now quite a bit. So classically, I said we get to the pellagra deficiency. So the 3Ds would have been what I learned about back in naturopathic school and biochemistry. And the 3Ds stood for diarrhea, but you can have B3, diarrhea, constipation, indigestion, all kinds of things subclinically can be related to poor B3 status. The second D was dermatitis, right? Like a really specific type of scaly rash. So all the B3s are really important for skin health. And the last three, they would say dementia, but it was used in a different way than we use that term now, and had to do with mood, like irritability, nervousness, but also loss of memory, confusion, brain foggy kinds of things were all bundled in that third D. And so getting back to like that dysbiosis with aging, like the GI was one of the classic indicators of B3 issues. And there's now, and this has largely been preclinical, though there is a NR twin study where they looked at the microbiome and each of the different
nicotinamide riboside.
Correct.
Yeah. Okay, go.
Seem to have an impact on the gut microbiome. NR, like in an animal model, actually rejuvenated stem cells in the gut. So even before these, forms of B3 or NAD plus precursors are absorbed, they have an potentially really big impact on our digestive system and the gut microbiome.
And I just want to add the fourth, isn't it? Death?
Death is the fourth, yeah, if you don't correct it.
Maybe you were going to add that in later.
Well, hopefully no one listening will get there or even close.
Yeah, nobody's going to get there but it makes me think of, it's just such a, it's a molecule in incredibly high demand. Like I always think of gut issues, skin issues in combination. There's massive cell turnover going on in both of those organ systems. And so they would show up first and prominently, and, they're just high energy demanding tissues, and it, stands to reason. And then I just remember from biochemistry as well, tryptophan being involved in making NAD, and, maybe there's a connection there to what's happening in the central nervous system, with regard to, mental health.
This would be the general estimate. It would take about 60 grams of tryptophan to build the equivalent that 1 gram of, say, flushing niacin would build of NAD. So it's like a 60-1 ratio, but that's an average. I've seen some studies that women are a little less efficient at using tryptophan than men, but ballpark, it takes a lot of tryptophan to accommodate, but you could, with enough, correct a B3 deficiency, at least in theory.
Right. And I guess I was more thinking about maybe the secondary role. I was just, sort of waxing incorrectly on what might the mechanism be for driving, the so-called dementia piece.
Yeah, and I'm sure it ties in because most tryptophan will be funneled into the serotonin pathway, relatively small amounts into what's called the kynurenine pathway, is what leads eventually to NAD+. Though I might actually have that flip-flop. But anyways, there's two enzymes that would be the first step. And either one can get the ball rolling, and one of them is very, very much upregulated by acute inflammation. So when there's any kind of trauma inflammation, our cells try to make a lot more NAD+, starting from these precursors, whether it's the NR I mentioned or tryptophan that you mentioned.
All right. We could keep going down this path, because probably this is one of the ways that we're just less efficient, or we're driving it towards, some inflammatory response as we age. Maybe this is one of the buckets. But all right, so you left off with talking about the gut. I think did you want to move through any of the other hallmarks to just link it to NAD?
Yeah, so other ones, like another one is chronic inflammation. So as I mentioned, that will deplete NAD for a variety of reasons. Then other ones like telomere attrition, they're more indirect. So, but there is one that has to do more with nutrient signaling, intracellular communication. Those are two other ones. Sirtuins, PARPs would be in that intracellular. Autophagy, again, be a little bit more indirect than direct. So the big ones for sure, DNA, mitochondrial dysfunction, intracellular signaling would be rock solid. All the other ones are a little bit more indirect. And then the other thing, and this has been observed in organisms all the way up to and including humans, is our NAD levels inside cells just goes down progressively as we get older. And that was one of the links to, I guess, building the case for why NAD becomes important. And I just saw literally this morning in a link to a new study, and it was in a worm model, right? So like a lot of the basic biochemistry of aging looks there. And what they found is that every way of building it, whether you started from nicotinamide, nicotinic acid, tryptophan, that all of those enzyme systems were less efficiently functioning as these organisms got older. And that maps to what I've seen in other organisms as well, that we just become a little less efficient in the enzyme systems that make this really crucial molecule as we get older.
I have two thoughts on what you've said. One is that we use it I was just doing a little review before you and I hopped on this podcast, and it's a player in over 500 reactions. Like, we're using it all over the place in incredibly important reactions. And so, if we're petering out on our ability to make it, it's just going to be really profound. And then on the potential influence of the deficit of this molecule. And the other thing that I was thinking of is you've brought up mitochondria a few times already, but again, in my little preview, just getting my brain in the space of thinking about NAD, it's a player in, well, not only the electron transport chain, it's cellular respiration, but it's all right there in the Krebs cycle and elsewhere. It playing incredibly important roles in the mitochondria. I mean, it's got to just be, if you wanted to top 10 mitochondrial molecules, it's got to be just right up there.
Yeah, I mean, ATP is probably number one. And I've heard it estimated that we make our body weight in ATP every day, because the turnover of that molecule is just so ridiculously fast. And I've seen estimates for NAD that we probably make and remake somewhere in the vicinity of 10 to 12 grams of the NAD molecule every day, which is a lot, right? When you think, and it doesn't spin quite as fast as the ATP molecule, but we are using recycling and remaking it quite a bit through the day just for our cells to do all their jobs for mitochondria. And then mitochondria, I'm sure I never learned this in biochemistry or naturopathic school, their role in making steroid hormones, right? The estrogens and testosterones and cortisol. And, so mitochondria do, crazy important things beyond just ATP.
What is its role in making steroid hormones? Is it actually providing precursor molecules or providing the energy? I mean, what is it?
That's a great question. I would probably be hesitant to answer because I might misanswer, but I think it actually is foundational in making the molecule.
I mean, I know we can, well, yeah, all right. Actually, I won't even, okay, but that's fascinating. Well, and all of those molecules require a bunch of energy.
Yeah.
So, but that's a lot, 500 enzymatic reactions requiring some form of NAD. When do we start to slow down our ability to produce it? I wonder if it's actually one of the, and would you, whatever this age is, like when does the aging phenomena, in your opinion, begin? And do you think there's an association with this molecule?
Yeah, so I think the person that's done the most testing is Ginfinity, that lab, because they've been doing their finger stick, which is just measuring whole blood. And one thing that would be for sure true, it would be a different rate of decline in different tissues, I think would be like fairly agreed. But what he would see is, at least in whole blood, a decade by decade decline, so that it would be in the early 20s at its peak for most people, and then each decade it would get lower in the number of tests that he's done. I saw something recently, again, animal study, but a lot of the animal studies is where we build our knowledge, that NAD was tied to ovarian aging, and that, that keeping that higher allowed fertility to occur later in the animal's chronological lifespan. So, that tissue in probably NAD is declining faster than in other tissues for women. Muscle tissue, as an example, this was a human study, and they measured younger people, older people, and then two different types of exercise, sprint type exercise or more endurance. And the older individuals that exercise maintained higher levels than the sedentary ones, with sprinting being better than the long distance running. And they still declined with age. So they maintained more, but they still were like ramping slowly downhill over time. So I know I've done my own NAD blood test several times. And if I'm not doing something to intentionally give precursors to build NAD, my levels are just suboptimal based on how Ginfinity would view. They set their optimal what the healthiest young 20 to say 25-year-old adults would have. And no matter exercise, sleep, all the things I would do to stay healthy, my levels would be below his optimal without paying attention to some way of supporting building it.
That's really fascinating. Ginfinity is the lab that you're using. I'm actually going to start measuring in practice. And you know what? I don't think you're not in clinical practice right now, are you?
No.
I'm going to actually track it with hormones and some of the associated compounds we're talking about, and see, what I notice. And then if I, when I supply precursor compounds, have you observed that in yourself? Have you observed a favorable change in other labs? And then we should talk about the clinical piece too.
Yeah. I've not measured, when I've measured NAD plus, my experiment has been, all right, let me go off anything with like a precursor. So anything that has nicotinic acid or niacinamide or DNRs, NMNs, or a lot of tryptophan for usually 30 days to see what I kind of baseline out then do an intentional stack of some sort. So Qualia NAD plus would have been what I did. And then do that for, 3 to 4 weeks and then reassess. And compared to my baseline without supplementation, the last time I did it, my NAD plus levels went up 149%. So a big change. And at least in the Ginfinity test, smack dab in the middle of what he would consider the optimal range.
Okay. What did you take? What was your dosing?
Yeah, so I just did 2 capsules of Qualia NAD plus, and I was like meticulous. I did it first thing in the morning, every day.
2 caps in the morning.
For that, yep. And
you don't have to divide
was sufficient. And
cool.
We can get a little bit into timing, but I do believe that the best time to take these NAD plus precursors is first thing in our morning, or with breakfast, but sometime early in the day.
Okay. All right. And that's great. We're digressing a little bit. And I know you're doing clinical research and, doing all sorts of really amazing stuff with humans. But I'm gonna stay in touch with you as I bring this. I have a micro clinical practice, but I'm just gonna start looking at this, Greg, a lot more
Yeah.
carefully than I have, and I appreciate you just really bringing it top of mind.
And
It's
there's
just fascinating.
more recently, Chromadex launched a finger stick kit as well, which I
Oh,
think you
cool.
can purchase
Good.
through Fullscripts for listeners that have access to that.
Okay. All right. Fabulous. Yay. This has changed. This is changing my practice. If any of my patients are listening, get ready. um, all right. How does it show up? How might somebody suspect NAD could be well, actually, and the thought that I wanted to share before you get into that is just thinking about declining, VO2 max levels, like this decade to decade drop. I mean, you can track a lot of the aging phenomena sort of in that decade by decade, but it makes me, think of it of NAD with that. So with that in mind, how does it show up clinically? Like who's going to be flagged?
Yeah, so I tend to go back to the 3Ds and then think lesser of those issues. But the thing we see on a positive in our, like, so far we've done a pilot study, a recently completed placebo-controlled study, and the things that show up the most commonly is feeling like there's more energy slash less fatigue, mood types of things. So, whether that's, apathy, nervousness, irritability, like a lot of the things that become more
Interesting.
extreme in that dementia
Yeah.
category of that. Energy would, fit in there as well. One of the more consistent things is feeling like sleep was more rejuvenating. So not necessarily sleep showing up on your aura or, wearable as I had more deep sleep, but not feeling as struggling to get through the day. Like your sleep just did a better job at restoring you. So I like kind of gets into energy, but there's a question that's very related to, feeling like your sleep was restorative that we use in our questionnaires in evaluating it, that always comes out strong in the people taking the Qualia NAD plus. And then, the other thing I would generally think of, and I think is, to me, this goes back to Brenner, right? His story is like, oh, this isn't about like you should feel it, though a lot of people seem to. It's
Mm-hmm.
about that our cells have more of this as a resource when they get stressed. And so, the way I would frame it if I was working with someone is that, like, if you feel anything from it, that's the cherry on top. The goal is the unfelt, that when our cells get stressed, that they have this resource to draw on so that they can, and I think of it as door 1 through 4, right? Like door number 1 is what we want. Like they're stressed, it's a hormetic stress, or they've got enough resilience that they respond and adapt and they're tougher for the experiment, right? Door number 2 is, stress was too much, they took on some damage, but it's repairable. So, that's a better choice than door number 3, which is becoming a zombie cell, right? Like now they're unrepairable. Or door number 4, it's so stressful they go right into apoptosis. So, to me, the most fundamental reason that we would want to make sure that we have adequate NAD plus stores is that when cellular stress happens, which in our world it happens a lot and sometimes unpredictably, that they can march through door number 1 or 2 and not go through 3 or 4.
I consistently used NAD, as a part of my stack a few years back, and then I've kind of forgot. I guess I tend to do perhaps less controlled N of 1 experiments on myself, and yeah, it feels fundamental. I mean, would you say that it's fundamental, like we think about magnesium?
Yeah, I think, and magnesium's super interesting. So one of the studies, like if it's okay, I'm going to go off on a magnesium tangent.
Go, go,
So
go.
one of the studies was James Clement, who's a really famous name in the researching longevity space, was the lead author on a study called something like the NAD plus metabolome and plasma is dysregulated with aging. And plasma is outside of blood cells, whole blood is inside. And there's a distinction there that is a little bit important. But anyways, the bottom line is no surprise in that study, compared to younger people, they evaluated the older people had less NAD plus in the plasma. But some other molecules in that metabolome, and the metabolome just means for listeners, all of the different molecules with an N in it. So NR, NMN, nicotinic acid, the NADH, the NADP that we talked about, right? Like the whole collection of molecules. So as an example, NMN was actually normal levels in the older group in plasma compared to the younger group, but NAD plus was decreased, right? Which then you'd think enzymes, right? Like is the issue. So at the time, I remember looking and thinking, like, this makes no sense. Like, why are some of the molecules what would be theoretically, normal, and other ones decreased? And one of the things that led me to was looking at just a biochemistry drawing, and then a couple of different drawings, and eventually finding two drawings that had ATP drawn in the biochemical pathways, and they didn't agree. Like, they each had ATP in some of the same spots, but not in some of the others. And so eventually, like, I looked up all of those enzymes, and it turns out like literally every single enzyme in the metabolome pretty much requires ATP. And the interesting thing about ATP is that NAD is required to make ATP, but you cannot make NAD, and you can't get good flux through the entire metabolome without ATP. And we know because of mitochondrial dysfunction, ATP goes down with age, right? So I think that ATP piece of playing a role in keeping the flux through this complicated network of molecules is just underappreciated. So that brings us to magnesium, because whenever you see ATP in any like drawing, it's usually left off, but in cells, it's always an ATP magnesium complex.
Well, it's because I know this because I was the lead author on the elements chapter in the laboratory evaluations textbook, and we included a figure of what ATP is doing. It's actually hanging onto the phosphates to keep them intact. And then as you bust them off, magnesium takes off and it recycles, and just like NAD, you recycle a massive amount of it, in that journey to make ATP. But that's what magnesium is doing. It's right in there, like just kind of hunkering down those wildly energetic phosphate groups as they get clumped up for energy, which I think is so cool. So yeah, you link them both intimately together. You just need them.
Yeah.
Good.
Well, I guess getting to your question, like, is this as foundational as magnesium? And it's like, yes. And
it really
magnesium,
is.
this is one of the reasons that's also foundational, and, hundreds of other reasons that magnesium is. But a lot of those, it's because of pathways that it's interacting with the ATP molecule to facilitate.
Yeah. That's nice. It almost causes a pause. Just like, let's take that in.
Yeah.
How important these compounds are, and the fact that we're just not making them as well. As you were dialoguing around how that deficiency will present on the aging journey, it just made me wonder about COVID, and COVID survival, and maybe even long COVID, and if, how these molecules are essential to have on board for our ability to respond.
Yeah, I mean, viral stress is just a different type of stress for cells, right? But the same principles are going to apply. Like when, a cell is stressed, if it has more resources, it's going to typically do a better job at being resilient to that stress. And if it doesn't, then it isn't. And so I do know there's been both preclinical and a little bit of human studies that have looked at COVID, and I think NR is what's been looked at more specifically. But it's critical, and I've seen a few animal models of things that would be more like traumatic brain injury, right? Like something where inflammation goes up, and if there's enough even of niacinamide available locally in the pool, then that region of the brain will perform better. It'll adjust to that stress quicker and bounce back better. So that's why I go back to that. It's about being prepared for stress. The subjective benefits we get, like those are the icing on the cake, cherry on top type of thing for me. It's, I want to make sure that my, cells are going to be as resilient as possible, and having adequate resources is a big part of that resilience game.
Right. What form is in the Qualia NAD?
We do a blend of nicotinamide riboside, nicotinic acid, and the nicotinamide. Niacinamide is sometimes the other way it's called. And partly we do that because there's a couple different ways to make the NAD plus molecule. We mentioned the tryptophan, so that's a long process. I think there's like 11 or 12 enzyme steps to go through. So and it's inefficient. But nicotinic acid, the flushing niacin, goes through NAD plus in something called the Price handler pathway. And so it's got a unique entryway into that. And it is something that for sure builds the NAD plus molecule. And then NMN, nicotinamide riboside, so NR or niacinamide, are all part of what's called the salvage pathway. And all of those at some point go through the same NMN to NAD plus enzyme. So just where kind of in that that group of molecules they plug in. But NR and NMN are pretty big molecules, meaning that, like in our diet, as an example, most animal products will have some of many molecules from the metabolome, right? They'll have NAD plus, they'll have the NADH, they'll have the NADP, et cetera. And it's been pretty known for decades and decades that enzymes in our digestive tract largely then break down the bigger molecules step by step to smaller molecules like niacinamide. And that what's interesting is NR and NMN, I'll sometimes see the different camps argue about which is better.
Yeah.
And one of the arguments always invariably comes to like, well, NMN's too big to get into cells. And that would be true in a passive sense, but if there's a receptor for it, it can take it in. But outside of our digestive tract, neither of those orally get to remote tissues in one place. Like those studies have been done many times, but they're all efficient at building the NAD plus molecule in remote tissues. And one of the things I think that's crazy underappreciated is that gut microbiome. All right, like the different forms probably slightly feed different organisms, right? Because they're going to break apart the molecule, feed on it. And one of the interesting things, super premature to say how it would translate to humans, but I think there's been 2 rat studies so far that if the gut microbiome doesn't break NR down into the N and the R, and then convert the N part from niacinamide into nicotinic acid, liver NAD plus levels don't go up. So my suspicion is there's a gut microbiome important piece to how efficient any of these different molecules are at building NAD plus in an individual. And it's rare in the human studies I've seen on NR and NMN, but when they've given each individual's data, it's really variable. Like on average, NR at 300 milligrams increases NAD 50%. There's going to be people way less than that and people way more. So some people like me with the Qualia NAD that had 100 and close to 150% increase, and that are others much less. And my guess is that some degree of that is microbiome driven.
Yeah. Hence your multiple forms. That's super smart.
Yeah.
Right?
Yeah. And because what would also have been done a while back is that certain tissues, some would prefer nicotinic acid to make NAD plus. Some might prefer niacinamide. So, one of my, I guess principles I approach is, let's not try to like block and tackle and think that we're smarter than cells, but let's give them more options to do what they want to do. And I tend to believe systems with more options available end up making better decisions and better outcomes over time. So I'd rather than just say, oh, this one form is the best and that's all we need, let's give options for making it and let different tissues sort out their
make the decision. Well, and to your point around the microbiome, it may act on the different structures depending, on the microbiome that you carry. It's it's going to have a different effect, likely, on the different structures. And so, if you only, it makes sense to me that you could get a very different bang for your buck given microbiome and perhaps, cellular demand out of individuals. I mean, there were similar data looking at the absorption of omega-3s. It's wildly variable. I mean, really the only way you're going to know if you're getting people to a reasonable level is to test.
Mm-hmm.
Why did you guys, you do not have NMN in your product?
Yeah, so as we were making Qualia NAD+, the FDA decided that NMN was no longer a dietary supplement.
Okay.
And so because of that, we decided to not include it. But NMN, like any of these things, will absolutely increase NAD plus levels in many, many people. So it's a good molecule. I think sometimes, like I said, there's a tendency to get into debates which is better. Well, they're all good. I think what makes the Qualia NAD plus somewhat distinctive, in addition to us, studying it and knowing that it works.
Yeah. And doing clinical research on it.
We, there is magnesium and there's low amounts of the other B complex vitamins because directly or indirectly, they're all involved in making ATP. And as I mentioned, like ATP is just so fundamental to making the NAD plus molecules that, I think it's smart to support that as well. And
you've got NR, so you've got the ribose molecule that will also support ATP.
Yep.
I just wanted to go back to the study that you referenced, and we'll link it in our show notes, everybody, around the NAD metabolome and how older adults had plenty of NMN. What does that mean? I mean, it makes me think that perhaps having a selection of other molecules makes sense in that regard as well. Am I thinking correctly, or what do you think?
Well, partly measured plasma, and loosely think of there being intracellular and extracellular NAD metabolisms. And the enzymes inside cells aren't all replicated outside cells. So that study may not exactly map to what would happen intracellularly. But in that particular study, like NAD plus levels were lower in plasma in the older group, but certain other things weren't. They were more consistent with what the younger group, and NMN being one. And, so right away then I think, okay, is that enzyme that can turn NMN into NAD plus extracellular? And the answer is yes. And that enzyme is activated by ATP, which there's much less ATP outside of cells, virtually none, right? Unless a cell is damaged, in pain or something where it's like effusing ATP out, right? So that was the main reason I brought that up, is it was what led me to this underappreciated role of ATP. But inside cells, ATP would be expressed. And so my guess would be the metabolome, if it was measured inside red blood cells or muscle cells, would look different with aging than in plasma.
Sure. Okay. All right. Let's see what else I want to ask you about. Anything? Well, I guess I have two questions. One, any other pearls to share from your clinical experience, your own experience? And then let's talk about dosing timing. So you've worked on some research. You do your own N of 1 research. You're pretty much always in a research study. And then I want to make sure we circle back to dosing and timing.
So I think one thing I periodically will hear someone say, you have to be careful of not making too much NAD plus. I literally have not seen that to be an issue in any of the NAD testing we've done. Ginfinity, the same. I asked him at one point. So I think there's always too many checks and balances in physiology for that. Another thing I see misrepresented a fair amount is that niacinamide will inhibit sirtuins, and so that's a bad form of things. And the reason I think that's disingenuous is severalfold. One, you would know end product inhibition, right? Like any product of an enzyme, if it builds up, will shut down that enzyme, right? That's just kind of basic biochemistry. And in vitro, in a cell culture, you can do things that would cause niacinamide to build up enough. But in cells, it either gets salvaged, and then the pathway goes niacinamide to NMN, NMN to NAD, or it gets methylated and eliminated. So methylation is a big way that we remove excess vitamin B3. And so in a living system, that becomes a moot point, right? Like niacinamide, if it builds up, then one of those two things happens. And the other thing is that no matter how we build NAD plus the first time, when it gets consumed, the leftover is always niacinamide. So if we built it from NR as an example and measured niacinamide in the blood, we would see it go up, even though we gave NR. If we gave NMN, we would still see niacinamide go up. Because if we gave flushing nicotinic acid, which is different than niacinamide, we would still see niacinamide go up, because no matter how you make NAD plus,
all points
eventually lead in the consumption role to niacinamide going up. So I think that, it's always saddens me when I see smart people, say things like that, often with an agenda, right? Because they're promoting their NMN or NR or something as better. That said, the NRs and NMNs in my testing work better than just niacinamide for more reliably promoting at least red blood cell increases.
Okay, cool. All right, in using Genfinity.
Yep.
Okay, so any feedback from your clinical trials or your own N of 1?
Yeah, so my own N of 1, when I did it, I wouldn't say that I noticed. My sleep's good anyway. For listeners, I'm 62. I have no issues sleeping. It takes me like 3 or 4 minutes to fall asleep, and I usually sleep through the night. So I didn't notice sleep, which is a big thing anecdotally that shows up, as I mentioned. My energy is fine. So I really honestly didn't notice anything different, in my N of 1 subjectively. But in our studies, we've used the SF36 by Rand a lot in that. And that's a general health questionnaire that has 8 different buckets. One's energy and fatigue. So we've consistently seen that improve. We haven't always been powered we would think of that as a secondary endpoint. So we haven't always been powered to see a statistical significance, but we always see a better increase in that subscale than we do in the placebo group. Emotional well-being or mental well-being is another subscale. That one, the same. Consistently see a much better improvement in the questions related to that. There's another one that has more to do how emotional issues impact your ability to work and get through your day. We also see a consistent, much better increase in that one as well. The pain, physical, those have been usually better than placebo, but not quite as dramatic. So that energy, fatigue, and emotional, by far, are where I've consistently seen it show up subjectively. And then, as I mentioned, sleep, but more sleep in the context of feeling like you're more rested as you get through your day. And then a piece I've heard, but we've not tried to study, is recovery from exercise quicker. There's a lot of anecdotal reports of people just feeling like they bounce back quicker, especially as they're getting older from exercise if they're doing things to boost NAD+.
All right, so with the molecule, you're really not supposed to feel anything with it. You guys consistently, people are consistently feeling pretty great in some key areas. I mean, I think 70% of, patients seeking out medical care, people seeking out medical care is the complaint is fatigue. It's like a top complaint. It's probably greater than that. And how long was your study, out of curiosity? Like, when did the people notice these?
Yeah, so our studies have been 28 days. And
short.
So usually by about 14 days is when the subjective symptoms are separating, noticeably from the placebo group. And then in addition to the SF36, we've used what's called the Aging Male Symptom Scale. Think of it as a low T-ish type of scale. And then we created our own female version of that shares many of the questions and then makes a few specific just to have a similar thing for women. And in the latest placebo study we did on that, there's three subscales of that: a sexual one, a somatic, and a psychological. And the psychological, again, it's, the irritability, nervousness, mild mood issues. And the somatic has to do with, again, like, fatigue and bodily sensations. And what was interesting is that actually was statistically significant in women in the somatic and the psychological scales. Again, over 28 days. And in men, we didn't see a statistically significant change. But again, it groups into those same things we talked about, right? Like a lot of things that go to the brain and energy.
Yeah, well, and hormones, potentially. I'm really curious about that. Wow. All right. What else do we need to talk about? Oh, just timing. You were going to circle back and talk about, timing and dosing.
So, like timings, so like chronobiology, like the when of things has been an interest of mine since, like around 2000. I think one of my 2-part articles on AltMed Review was about the variability of body temperature with paying attention to circadian rhythms. But, the default often is, well, let's just give something twice a day and, call it good. And, studies, many of the NR or NMN studies are like that. They'll, breakfast and dinner.
Just cause? What's the rationale for that? Just cause?
It's just cause, right? Like, it's just the default, right? Is like timing does not get factored in often. So again, animal study, so take this with a grain of salt, but in an animal study, they infused NAD, so intraperitoneal, at either the beginning of their active cycle or the beginning of their rest cycle. And so the time of day would flip-flop, right? Because they're nocturnal and we're not. But when they gave NAD plus at the beginning of the day, things related to metabolic health improved that they measured, right? Your insulins, your glucose, your liver enzymes, things like that. When they gave the NAD plus infusion at the beginning of their rest period, so the equivalent of our night, it actually worsened all of those same things.
Interesting.
And so then in that study, they decided, okay, well, let's follow that up and give niacinamide, right? That form of B3, also timed, and it was the same. Niacinamide bolused all at the beginning of their day equivalent, made a positive impact, and at the end, not so great. And, so there's that piece of evidence. There's several different studies in humans that in small numbers of people have tried to look at NAD plus levels in the blood in a circadian sense. And it seems like for most people, it peaks somewhere early to mid-afternoon, right? And if we were to take, say, niacinamide or NR orally, it takes a bit to get through digestion, make it in the liver, get released into circulation, and then peak in the blood. So to get that peak in, say, 2 in the afternoon, we would have needed to consume the NAD booster with breakfast, as an example. So I think when you start to stack the different evidence, the experiment I'm most comfortable running is just take all of it first thing in the morning. Maybe things don't play out exactly the same way in us as they did in that animal study. But when it comes to circadian functions, often, if something has a circadian rhythm in one organism, it will have it in all of us.
Elsewhere. And and it just makes life easier, for everyone. You can just bang it out in the morning. Well, this was great. It's funny. We have our producer is listening in, and I know his wheels are turning. He wants to start taking it. It just makes a lot of sense, and I'm gonna really focus on it in my practice with some intentionality and actually run the Ginfinity test. And I think we'll link and then you said Chromadex. Maybe we'll just, if it's okay, we'll throw some of those if people want to actually start measuring. And you are bringing it into clinical practice. We'll throw some of those links on the show notes page. I want to remind people too, by the way, that if you go to qualialife.com/Dr. Kara Fitzgerald, that's Dr. Kara Fitzgerald, you'll get a really nice discount, like a heavy discount. There's already a discount built in, and then you can layer an additional. So you could get like up to 50-65% off to start it. So that's awesome. All right, with that, just tell me anything you want to talk to me about with regard to what's coming for you guys over there at Qualia/Neurohacker.
Yeah, we'll be, so sometime end of Q1 2025, we'll be launching, I think, what's going to be called Qualia Joint Health. But we did a pilot study of that. So think of it as something for like healthy joints and targeting that chronic inflammaging type of hallmark. So that's exciting. We have a bunch of other things kind of somewhere early in the development pipeline. So that would be the next thing. But I've been working on lots in the longevity researching ingredient space. You and I talked offline not too long ago, and I'd say over the last 4 months, that's been our emphasis is just to get smarter on all these different compounds and figure out which ones look the most interesting. Many of them, the research is still premature, but like polyphenols come up a lot, right? As super cool. I think glycine is really interesting. So we'll do something more, continue to do more in the, what, for lack of a better way to describe it, is the longevity category. And then we're somewhere in the midst of doing a hydrogen tablet that has a Qualia proprietary blend that will be built in. That's probably a Q2 next year. Recently, we launched the Qualia Magnesium Plus, which for listeners, when I think of like what really works, magnesium is one of those things, and that many people actually do notice an impact. So, that's something if people want to check out. And then, it's always cool things. And one of the things I really like about the Qualia brand and working for them is that before launching any product, I'm allowed to put prototypes together and actually do a human study to make sure that they do what they're supposed to do. So I guess the final thing with Qualia NAD Plus is we've done 2 of those compared to placebo, and the first one, it was an average 74% increase in NAD. The second one was an average of 67%. So, there's other NAD boosting things out there. The one thing I can say is I know with confidence ours works because we've studied it.
You've tested it. Yeah. That's exciting. It's really exciting. Well, geez, I hope that you can circle back and share with us some of the other launches you guys have coming and especially just the research. And then it's always fun to talk to you about the mechanisms and what's going on intracellularly and just a sweep of the research more broadly. So as always, Greg, thanks. It was awesome to have you here. It was really good to connect.
Oh, thanks for having me today, Kara.
As always, thank you for listening to New Frontiers in Functional Medicine, where our sponsors help bring you the very best minds in functional medicine. These are brands that I know, I trust, I use in clinical practice, and I can confidently recommend to you.